So today I will be discussing about the class 9th first basic chemistry chapter, matter in our surroundings. So before we start this lesson, so make sure that whatever I discuss and the points which I write, please note it. So this will be helpful for your upcoming test or examinations or whatever you are going to attend in your school or in the tuition test. Okay, right. So let me now begin this chapter by explaining the basic word of this lesson, that is called matter. So we have to know first of all what is the meaning of matter, or how can we describe matter. See, basically matter is nothing but anything that is present in this universe which has mass and which occupies space. I'm telling matter is anything that is present in this universe. See, you can see so many objects are being given on the screen. It may be probably, you can see there are, see, just a minute. See, you can see there is a pencil, there is a skating board, there is a table. See, and you can also see some of the snowfall which is being represented here, the bicycle, like this. If we keep naming, we see n number of things in this universe. So anything that is present in this universe, okay, has some mass. What is the meaning of mass? The meaning of mass is nothing but weight. In chemistry, the meaning of mass is weight. Okay, so anything that is present in the universe which has mass and which occupies space. So what is the meaning of space? Space is the place that is occupied by an object. Okay, say for example, now I am holding a pen in my hand. If I want to keep this pen on this table, this pen will occupy some space. Okay, so if this pen is occupying some space, I can consider this pen as a matter. Okay, and even if I keep this pen on a weighing machine, definitely this pen also shows some kind of weight. It may be 10 grams, 20 grams, 50 grams, whatever the weight it may be, but definitely it has some weight. So if I'm considering this as a matter, you take anything that is present in this universe. You take your textbook or the place where you sat by using your chair. Even the chair is also a matter. Okay, you can take anything from the micro thing till the macro things. Anything that is present in this universe will be definitely having some weight, and also those materials or the objects or the substances definitely occupy some space. So hence we can consider them as matter. So after understanding the definition of matter, it is the time to write the definition. Okay, please note down what is the definition for matter. So what is matter? Matter is anything in this universe. Anything, okay? Matter is anything in universe. Anything in universe which has mass and occupies some space. Which has mass and occupies space. So this is what we can call matter as. So now after understanding the definition of matter, we have to know how this matter is classified. So let us talk about the ancient classification of matter, children. See, basically when I talk about ancient classification of matter, our ancient Indian philosophers. So I'm talking about Indian philosophers who were actually present in the ancient times, very olden days I'm talking. Okay, so our ancient Indian philosopher, they have classified the matter into 5 elements. Okay, I repeat, our ancient Indian philosophers, they have classified the matter into 5 elements. So which are the 5 elements which they have classified the matter into? The 5 elements which they have classified the matter into are, namely, they have classified as earth, air, sky, water and fire. So these are the 5 groups the ancient Indian philosopher classified the matter into. Okay, they have classified the matter into 5 elements, I told. Okay, these are the 5 elements. Which are the 5 elements? The 5 elements are namely the earth, air, sky, water or maybe the fire. Okay, and after classifying these this matter into 5 elements, they have considered these 5 elements as Panchatatvas. They call these elements as Panchatatvas. In Kannada, we say it as Panchatatvagalu. Okay, so anything that is present in this universe, ancient Indian philosophers told them as. So, who are these people? Ancient Indian philosophers. Ancient Indian philosophers, they have classified the matter into 5 basic elements. Okay, and they told everything that is present in this universe is either made up of air, or it is one of the component of sky, or maybe the component of water or fire or the earth. But later on, in the later stages, modern day scientists have arrived. Modern day scientists have arrived and they have classified the element, that is the matter, into different groups, children, on the basis of different properties. Okay, how are the matter classified by these modern day scientists? See, modern day scientists have classified the matter based on the physical and chemical properties, children. Physical and chemical properties. So then, what is the meaning of physical properties? Physical is nothing but anything that you see from outside. For example, see, I am holding pen in my hand. So if I just say, if I ask you, how is this pen looking? You say it is looking like, hard substance, and you can say it is a solid. Something you can describe about this pen, right? No. How is it possible to describe? It is possible to describe just by looking its physical appearance. Okay. Any matter, if you are describing just by looking from its outer look, that is called as physical. Okay, anything that you describe just by looking its outer appearance, it is called as physical. Is that clear? And if I ask, what is this pen made up of? The pen is made up of plastic. And what are the components of that plastics? You don't know. It is because the pen is made up of plastic, you are aware about it. But what are the components of plastic? You don't know. So that is called the chemical properties. So what are the chemicals that are being added in order to prepare this pen is the chemical properties. Okay, and in this chapter, we will talk everything that is related to physical properties, children. We don't talk about chemical things, rather we will talk about physical things. Okay, so I'm just explaining all the concepts in a very simplest way. I repeat once again, if you want, you can please note down and recall the points which I have told till now. Firstly, I told you what is matter. So how can we describe the matter as? Matter is anything that is present in this universe which has mass and which occupies some space. If I say anything, children, make sure this may be the micro thing or maybe the largest thing that is present in the universe. Okay, anything that is present in the universe, if it is having a slight weight, it may be the weight may be it is in the micrograms also, not an issue. But if it is showing some kind of weight, definitely we are considering it as matter. Later on, this matter was classified by many people, like ancient philosophers has classified the matters based on their thinking. Later on, some scientists have come in the modern days. They have classified the matter into the different things based on their observations, based on their experiments. Lot of things went on. But remember, whatever the things that are being said by ancient philosophers, that was just their assumption. Nothing was being experimentally proved. Okay, so as a result of it, they have classified, the ancient philosophers have classified the elements into the matter into 5 elements. The 5 elements which they have classified the matter are namely earth, air, sky, water and fire. And remember, they told everything that is present in this universe is made up of these 5 elements only. Okay, and remember, this was totally been described differently by the modern day scientists. They told everything that is present in the universe is not based on the 5 elements called Panchatatvas. Rather, everything that is present in this universe is completely based on the physical and chemical properties. I told you, what is the physical property? Anything that you see from outside and you describe the property about it, it is called as physical. And if you are not able to describe just by looking its outer look, it is something which is related to their composition, then it is called as chemical properties. Okay, so I hope I made you clear. So let me move for the next, children. So next we are going to talk about some of the concepts, basic concepts of this lesson today. Basically, what are the things that we study in this lesson? The key points of this lesson that we study are, namely, we will talk about the physical nature of the matter. Firstly, we will talk about the physical nature of the matter. Secondly, we will talk about the characteristic particles of matter. We will talk about characteristic particles of matter. Characteristic particles of matter. Thirdly, we will talk about states of matter. States of matter. And next we will talk about interconversion of matter. Interconversion of matter. And finally, we will discuss about a concept called evaporation. So these are the key points of this lesson, children. Firstly, I will start with the physical nature of matter. Okay, I'm starting with what? I'm starting with physical nature of matter. And I told you in this lesson, whatever we study is completely related to physical things. We are not going to discuss any kind of chemical composition of matter. So now, before starting the physical nature of matter, I would like to ask, and I would like to also give the conclusion about certain types of matter. So I'll just tell you, you just now think in your mind whether they are matter or not. Okay, so I will write some examples here. Say now, if I write chair, okay, chair, can I consider the chair as a matter? Definitely yes. Why? Because chair has mass and chair also occupies some space. What about, say, if I take some air in the balloon, okay, air which is present in the balloon, air in the balloon. Is air in the balloon is a matter? I hope you're getting my point. I'm just telling you, I just blown some air in the balloon. So what happened to my balloon? The balloon got increased by its size. Okay, so I have air in the balloon right now. Is air present in the balloon is a matter? Definitely yes. Why? Because the moment I blow the air in the balloon, what happened? Air occupied some space. And if you keep that balloon over some weighing machine, it may show some micrograms. Definitely it can also be considered as a matter. Say for example, now your mother is cooking food right now in the kitchen. She might be preparing dinner right now. Okay, so while she is preparing the dinner, you get a smell, even you're sitting very far away. Right? So now can I consider the smell as a matter? Definitely not. Smell cannot be considered as a matter. Now you and your friends are very close. You love each other. You have respect about each other. So now can I consider the love or the respect that you have on each other as a matter? Definitely not. Why? Because the smell, the love, the respect, they are all feelings. They are all thoughts. Okay, they do not have any kind of mass and they do not occupy any kind of space. Okay, something which is not occupying space and mass cannot be considered as matter, children. I hope you got a clear idea like what we can consider as a matter, what we cannot consider as a matter. Your thoughts and your feelings cannot be considered as a matter. But any kind of material, it may be a smaller or a bigger, if it is occupying space and if it is having mass, definitely it is called as matter. Okay, so as I told you that I will be talking about the physical nature of matter, let me start with the first physical nature of the matter. Okay, the first physical nature of the matter is, first physical nature is matter is made up of small particles. So I will show you and I'll tell you how is this statement is going to be proven. Okay, matter is made up of small particles. Okay, small particles. And the second point is particles of matter are very small. Particles of matter are very small. Okay, these are the two physical nature, or we can say physical properties of matter. Physical nature or physical properties of matter. The first one, see, I have a glass of water with me. You can see, I have a glass of water in my hand. Just a second. Okay, so you all can see there is a glass of water in my hand right now. Okay, right? So this glass of water which I am holding right now, okay, to this glass of water, let me add a small amount of salt. I am taking some amount of salt and I am adding this salt to the water. Okay, after adding the salt to the water and I am giving a nice stir. Nicely I am stirring the salt in the water. So after stirring, what am I doing? I'm just holding in my hand, the same glass I'm holding in my hand. I'm observing for the salt particles. See, after you add salt to the water and after stirring nicely, can you see the salt particles in the water? You cannot see any kind of salt particles because you have stirred nicely and the salt particles got completely dissolved in the water. Correct, no? So what is salt now? I can consider salt as a matter. Correct, because salt occupies some space and salt also has some mass. And that salt, when I add it to the water and when I nicely stir, what happened? The salt particles got broken down. Okay, salt is a matter. I repeat once again, listen to it properly. Salt is a matter. The salt being a matter, when it is been added to the water, the particles of that salt further got broken. And those particles, after further breaking, they entered into the water. Where exactly it entered into the water? It actually entered into the water between the space present between the particles of water. You know that water being a liquid, the molecules of water, that is the molecules present in the water, has some space between them. Okay, water is not rigid. Okay, when I take the water in this glass, the water is occupying the shape of the glass. If I take the water in some other container, it takes the shape of that container. That means the molecules of the water has certain gap between them. And when I add salt to the water, what happened? Those salt particles, when further broken down, the particles of salt took the place or the space that was present between the particles of water. Okay, so as a result of it, what happened? The salt particles which got further broken down occupied the space between the particles of water, that is the molecules of water. So by this activity, I can say that particles, that is matter, is made up of small particles. Just remember, just think that when I add salt, if salt was not made up of small particles, all the salt particles would have been suspended in the same way in the water, or it would have been settled at the bottom of the water. It does not happen. Atar aglila. Yake? Why? Because all the salt particles further got broken down and they occupied a space that is present between the molecules of liquid or the water. Okay, this activity proves that, okay, matter is made up of small particles. The next question we can ask ourselves, how small the particles of the matter are. I told you matter is made up of small particles, but how small these particles are. Okay, to explain this, I have a figure on this, the board which I'm just showing to you right now. So let me just scroll down that image. The first activity which I explained is related to this particular image. This particular image is what we have seen through the glass which I have showed right now. Okay. See, I just explained this activity. So this activity says that matter is made up of what? Made up of small particles. Matter is made up of small particles. Okay. So we are now understanding the second physical property of the matter, that is particles of matter are very small. Nan helde, ask a question for yourself. I told you matter is made up of small particles, but how small the particles of matter are? To make you understand that particular concept, I have a figure on this board. You can see. See, firstly, we have to take a beaker and fill the beaker with 100 ml of water. ಒಂದು beaker ತಗೊಳ್ಳಿ, just fill that beaker with 100 ml of water. To this beaker, now I am adding a spoonful of potassium permanganate. So potassium permanganate formula is KMnO4. It is basically purple color crystal, children. It is purple color crystal. Okay, purple color crystal. Okay, I am taking some potassium permanganate, that is KMnO4, and adding that potassium permanganate to the 100 ml of beaker which is containing water. And after adding, I am nicely stirring it. ನೀಟಾಗಿ ಸ್ಟರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸ್ಟರ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, the potassium permanganate which was purple in color has discharged its color to the water, and you can see the initial color of the water was colorless, and now you can see what is the color of the water. The color of water has changed to dark pink. Okay, so now what I will do is I will take another beaker. So here I am taking another empty beaker. To this empty beaker, what I will do is I will take again 90 ml of water. Now here I will take 90 ml of water, children. This is, they have shown after the change in color. Okay, now I would like to explain you before change in the color, what are the observations. After change in the color, what are the observations. So here I will take 90 ml of water again. So let us consider this as beaker A and this as beaker B and beaker C. Okay, even in the beaker B and beaker C, what am I doing is I am taking some amount of water. In beaker B and beaker C also I am taking some amount of water. So what I am doing here is, ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, I will collect 10 ml. I will collect 10 ml of solution from the beaker A, that is a dark pink color solution, and after taking this 10 ml of dark pink color solution, I am adding this dark pink color solution to my beaker B. Okay, how much amount I have taken? I have taken only 10 ml. I am adding it to the beaker B which is containing 90 ml of water. So 90 ml of water ಗೆ 10 ml of a solution ಅನ್ನು add ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, finally it will become 100 ml. ಸೊ ಈಗ 100 ml ಆಗೋದಲ್ಲ ಅಬ್ಸರ್ವೇಷನ್ ಏನು ಅಂದರೆ, the moment you add the pink color solution to the beaker B, what happened? Just a minute. The moment you add pink color to this beaker, what is happening? My solution, that is the water which was earlier colorless in solution, the water which was earlier, just a second children, the water which was earlier colorless in solution, what happened? It has discharged the pink color into it. ಇದರಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಪಿಂಕ್ ಕಲರು ಇದರಲ್ಲಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಗ್ತಾ ಇದೆ. ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿ ಏನಾಗ್ತಾ ಇದೆ, the 90 ml of solution has changed its color. But what is the difference? Beaker A ನಲ್ಲಿ dark pink color ಇತ್ತು. ಆ dark pink color solution ಅಲ್ಲಿ you have taken only 10 ml and you have added to 90 ml of clear water, and here ಏನಾಗ್ತಿದೆ ಅಂದರೆ, you are getting one shade less pink color in the beaker B. Okay, beaker A ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ beaker B ನಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, the color is comparatively less compared to beaker A. ಬಟ್ ಈಗ ಕಲರ್ ಬಗ್ಗೆ ಮಾತಾಡೋದಕ್ಕಿಂತ ಏನಾಗ್ತಾ ಇದೆ, ಸೊ ಬೀಕರ್ ಎ ನಲ್ಲಿದ್ದಂತ ಈ ಪಿಂಕ್ ಕಲರ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾಡ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್. ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್? ಐ ಹ್ಯಾಡ್ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್ ಪಾರ್ಟಿಕಲ್ಸ್. ಈ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನ ಯಾವಾಗ ನಾವು ಬೀಕರ್ ಬಿಗೆ ಆಡ್ ಮಾಡ್ತಿದೀವಿ, ಆ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮಾಂಗನೇಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಾ ಇದೆ, ಫರ್ದರ್ ಇಟ್ ಈಸ್ ಡಿವೈಡಿಂಗ್. ಏನಾಗ್ತಾ ಇದೆ, ಫರ್ದರ್ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. ಫರ್ದರ್ ಅದು ಬ್ರೇಕಪ್ ಆಗ್ತಿರೋದ್ರಿಂದ ವಿ ಗಾಟ್ ಸಮ್ pink color solution even in the beaker B. But it is not completely like beaker A. It is little bit lighter compared to beaker A, but still we got the color. Okay, so here I can say that the potassium permanganate particles which I have taken in the beaker A, that is which was there in the beaker A and which I have taken in the test tube for almost 10 ml, got further divided. Okay, potassium permanganate ಏನು ತಗೊಂಡಿದ್ದೆ ನಾನು 10 ml, ಆ ಸೊಲ್ಯೂಷನ್ನು ಬೀಕರ್ ಬಿಗೆ ಹಾಕಿದಾಗ ಏನಾಯಿತು, ಫರ್ದರ್ ಡಿವೈಡ್ ಆಗೋಯ್ತು. ಸೊ ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಆಫ್ ಇಟ್ ವಾಟ್ ಹ್ಯಾಪನ್, ದ ಬೀಕರ್ ಬಿ ಗಾಟ್ ಚೇಂಜ್ ಇಟ್ಸ್ ಕಲರ್. ದಿಸ್ ಶೋಸ್ ದಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್ ಆರ್ ಸ್ಮಾಲ್ ಅಂತ ಹೇಳಿದ್ದೆ ಈ ಕೇಸಲ್ಲಿ, ಆಯ್ತಾ. ಇಲ್ಲಿ ಸ್ಮಾಲ್ ಆಗಿತ್ತು, ಬಟ್ ನಾನು ಫರ್ದರ್ ಈ ಸೊಲ್ಯೂಷನ್ಗೆ ಹಾಕಿದಾಗ ಏನಾಯಿತು, ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ದ ದಟ್ ಈಸ್ particles of matter are small anta helidnalla. How small the particles are? The particles are very very small. ಯಾಕೆ ಅಂದರೆ ಇದು ಫರ್ದರ್ ಆ್ಯಂಡ್ ಫರ್ದರ್ ಆ್ಯಂಡ್ ಫರ್ದರ್ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. ಹೆನ್ಸ್ ದ ಕಲರ್ ಆಫ್ ದ ಬೀಕರ್ ಹ್ಯಾಸ್ ಚೇಂಜ್ಡ್. ದಟ್ ಮೀನ್ಸ್ ದ ಸೊಲ್ಯೂಷನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಬೀಕರ್ ಹ್ಯಾಸ್ ಚೇಂಜ್ಡ್ ಇಟ್ಸ್ ಕಲರ್ ಅಂತ ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಕಲರ್ ಆಫ್ ದ ಬೀಕರ್ ಅಂದರೆ ವಾಟ್ ಇಸ್ ದೇರ್ ಇನ್ ದ ಬೀಕರ್? ಆಬ್ವಿಯಸ್ಲಿ ವಾಟರ್ ವಾಸ್ ದೇರ್. ಸೊ ವೆನ್ ಐ ಆಡೆಡ್ ದಟ್ ಸೊಲ್ಯೂಷನ್, ದ ಸೊಲ್ಯೂಷನ್ ಗಾಟ್ ಚೇಂಜ್ಡ್ ಇಟ್ಸ್ ಕಲರ್. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನಾವು what will I do is, now I will collect some 10 ml of the solution, potassium permanganate solution from the beaker B, and after collecting this 10 ml of solution from the beaker B, now what will I do is, again I will add this solution to my beaker C. Beaker C ಗೆ add ಮಾಡ್ತೀನಿ. When I add this solution to beaker C, ಏನಾಗುತ್ತೆ ಅಂದರೆ, in the beaker C you may get little bit lighter shade. ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, beaker C ನಲ್ಲಿ beaker B ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ you will get lighter than the beaker B. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಏನಾಗ್ತಾ ಇದೆ, ಪಾರ್ಟಿಕಲ್ಸು ಕಲರ್ನ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೆ. Potassium permanganate particles, when it has been added to beaker C, further it is getting divided. On further division, the 90 ml of solution has changed its color to little bit lighter pink compared to the beaker B. Beaker B ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ beaker C ನಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, one shade ಏನಾಗ್ತಾ ಇದೆ, ಲೈಟ್ ಆಗ್ತದೆ. 90 ml ಗೆ 10 ml ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಯಿತು, again this solution has changed it to 100 ml. Okay, this is a very simple activity, yet children, it's a very important thing. So what you are observing here is, on repeated addition of solution from one beaker to another beaker, the particles are further dividing, and as a result of it, we are getting the lighter shades of solution from one beaker to another beaker. This shows the particles of matter are very very small. The particles of matter are how small? They're very very small. Is that clear? So these are the physical properties of matter. These are the two physical properties of matter which you have to clearly understand. Okay, now let us go for the next. So next I am going to explain you about the characteristic particles of matter, and a very important concept of this chapter. 2 mark ಗೆ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಅಥವಾ ಟೆಸ್ಟ್ ಅಲ್ಲಿ ಕೇಳಬಹುದು. Characteristic particles of matter. I am explaining about characteristic particle of matter. Characteristic particles of matter. So what is the first characteristic particles of matter? The first characteristic which I am explaining you here is, particles of matter have space between them. Particles of matter have space between them. They have space between them. How can I give the proof for this? ಫಸ್ಟ್ ಆಕ್ಟಿವಿಟಿನಲ್ಲಿ ನಾನು ಏನು ತಗೊಂಡಿದ್ದೆ, ಫಸ್ಟ್ ಆಕ್ಟಿವಿಟಿನಲ್ಲಿ ನಾನು ವಾಟರ್ ತಗೊಂಡಿದ್ದೆ. ಐ ಟುಕ್ ಗ್ಲಾಸ್ ಅಂಡ್ ಐ ಟುಕ್ ವಾಟರ್. ಈ ಗ್ಲಾಸ್ಗೆ ನಾನು ಏನು ಆ್ಯಡ್ ಮಾಡಿದೆ, ಈ ಗ್ಲಾಸ್ಗೆ ಐ ಟುಕ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಲ್ಟ್, ಅಂಡ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಲ್ಟ್ನ ನಾನು ಏನು ಮಾಡಿದೆ, ಐ ಹ್ಯಾವ್ ಆ್ಯಡೆಡ್ ಟು ಗ್ಲಾಸ್ ಅಂಡ್ ಐ ಗೇವ್ ಎ ನೈಸ್ ಸ್ಟರ್. ಕ್ಲೀನ್ ಆಗಿ ಇದನ್ನ ಸ್ಟರ್ ಮಾಡಿದಾಗ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಏನಾಯಿತು, ಆಲ್ ಮೈ ಸಾಲ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಗಾಟ್ ಆಕ್ಯುಪೈಡ್ ಬಿಟ್ವೀನ್ ದ ಸ್ಪೇಸ್ ಪ್ರೆಸೆಂಟ್ ಬಿಟ್ವೀನ್ ದ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. This says particles of matter have space between them. Definitely ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಸ್ಪೇಸ್ ಇದ್ದಿದ್ರಿಂದಾನೆ ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಸಾಲ್ಟ್ ಏನಾಯ್ತು, ಡಿಸಾಲ್ವ್ ಆಗಿ ಇಟ್ ಟುಕ್ ದ ಸ್ಪೇಸ್ ಬಿಟ್ವೀನ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ವಾಟರ್. ಸೊ ಐ ಕ್ಯಾನ್ ಕ್ಲಿಯರ್ಲಿ ಸೇ particles of matter have space between them, but this depend upon the type of matter makla. For example, if I take some solid object, for example ಈಗ ನಾನು ಒಂದು ಮೌಸ್ ತಗೊಳ್ತೀನಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಈ ಮೌಸ್ಗೆ if I add some salt, if I take some salt and add some salt over this mouse, ಏನಾಗುತ್ತೆ, ಸಾಲ್ಟ್ ಇಲ್ಲೇ ಇರುತ್ತೆ, it does not go inside. ಯಾಕೆ? because this mouse is solid. Okay, solid ಅಲ್ಲಿ particles ಹೆಂಗಾಗಿರುತ್ತೆ, they are very very closely packed. Space is not there. But in case of liquid, space was there. In gases, the space is little bit more compared to liquid. Liquid compare ಮಾಡಿದ್ರೆ gases ಅಲ್ಲಿ space is higher. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So depending upon the matter, space will be there. Definitely, if space is there, particles of matter, that is other part, if I take some other matter, that matter actually can occupy the space between the liquid objects, between the liquid matter ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಅರ್ಥ ಆಯ್ತಲ್ಲ, ವೆರಿ ಕ್ಲಿಯರ್. ಸೊ ಐ ರಿಪೀಟ್, particles of matter have space between them. The best example is dissolving salt, sugar, or you can dissolve any kind of solution in the water. Clear? Second characteristic, we can talk about second characteristic. The second characteristic is particles of matter are continuously moving. Particles of matter are continuously moving. Continuous agi move agutte. Continuously moving. Okay, for this I will give you one example. See, again ಇದೇ ಗ್ಲಾಸ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ಈ ಗ್ಲಾಸ್ಗೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಕ್ಲಿಯರ್ ಆಗಿ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ಈ ಗ್ಲಾಸ್ಗೆ ನಾನು ಏನು ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಈ ಗ್ಲಾಸ್ಗೆ ನಾನು ಜಸ್ಟ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ದ ಇಂಕ್. ಈ ಇಂಕನ್ನು ನೋಡಿ ಈ ಗ್ಲಾಸ್ಗೆ ನಾನು ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ನಾನು ಇಂಕನ್ನ ಗ್ಲಾಸ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಏನಾಗ್ತಾ ಇದೆ, ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ ಇಂಕ್ ಈಸ್ ಸ್ಲೋಲಿ ಮೂವಿಂಗ್. ಕಾಣಿಸ್ತಿದೆ ಅಲ್ಲ, ಇಂಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಾ ಇದೆ, ಸ್ಲೋಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಲ್ವಾ. ಸೊ ಇಂಕ್ ಬೀಯಿಂಗ್ ಅ ಲಿಕ್ವಿಡ್, when I added to water, it did not stay at the surface. ಸರ್ಫೇಸಲ್ಲೇ ಉಳ್ಕೊಳ್ಳಿಲ್ಲ. ರಾದರ್ ಏನಾಯಿತು, ಈ ಇಂಕ್ ಏನಾಯಿತು, ಸ್ಲೋಲಿ ಇಟ್ ಪಾಸ್ಡ್ and it has spread everywhere in the water. So now I can consider ink is a particle of matter. And when I put this ink in the water, enaitu, ink slowly dissolved in the water. It slowly moved in the water. It did not stay at the surface. It slowly moved in the water. So through this activity I can say what? Particles of matter continuously move. Particles of matter continuously move. You can take one more example as agarbatti. ಸೊ ಇನ್ಸೆನ್ಸ್ ಸ್ಟಿಕ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅಗರ್ಬತ್ತಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಇನ್ಸೆನ್ಸ್ ಸ್ಟಿಕ್ ಆಗಿರ್ಬೋದು, ಅಗರ್ಬತ್ತಿ ಆಗಿರ್ಬೋದು, ಮನೆಯಲ್ಲಿ ಒಂದು ಕಡೆ ಲೈಟ್ ಮಾಡಿ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಆ ಅಗರ್ಬತ್ತಿ ನೀವು ಯಾವ ಏರಿಯಾದಲ್ಲಿ ಲೈಟ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತೀರಾ ಆ ಏರಿಯಾದಿಂದ ದೂರ ನೀವು ಎಲ್ಲೋ ಕೂತಿರ್ತೀರಾ, ಟು ದ್ಯಾಟ್ ಏರಿಯಾ ಯು ಗೆಟ್ ದ ಸ್ಮೆಲ್. ಹೌ ಇಸ್ ದಿಸ್ ಪಾಸಿಬಲ್? ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ದಟ್ ಅಗರ್ಬತ್ತಿ ಈಸ್ ಕೆಪ್ಟ್ ಮೂವಿಂಗ್. ಏನಾಯ್ತು, ಅದು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಮೂವ್ ಆಯಿತು ಆ್ಯಂಡ್ ಇಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಟು ರೀಚ್ ಯು. When it started to reach you, what happened? You could feel the smell of the agarbatti. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್ ಆರ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಮೂವಿಂಗ್. ಓಕೆ, ಆ್ಯಂಡ್ ಇನ್ನೊಂದು ಹೇಳ್ತೀನಿ ನೋಡಿ, ನಾನು ಏನು ಹೇಳಿದೆ, ಈಗ ನಾನು ಇಂಕ್ ತೊಗೊಂಡು ಏನು ಮಾಡಿದೆ, ಐ ಜಸ್ಟ್ ಟುಕ್ ದ ಇಂಕ್ ಆ್ಯಂಡ್ ಐ ಡ್ರಾಪ್ ದ ಇಂಕ್ ಇನ್ ಟು ವಾಟರ್. ಸೊ ಇಮಿಡಿಯೇಟ್ಲಿ ವಾಟ್ ಹ್ಯಾಪನ್, ದ ಇಂಕ್ ಸ್ಟಾರ್ಟೆಡ್ ಟು ಪಾಸ್ ಇನ್ ದಿಸ್ ವಾಟರ್. ದಿಸ್ ಇಸ್ ಕೋಲ್ಡ್ ವಾಟರ್. ಇನ್ ಕೇಸ್ ಆಫ್ ಕೋಲ್ಡ್ ವಾಟರ್ ಇಟ್ ಹಸ್ ಸ್ಟಾರ್ಟೆಡ್ ಟು ಮೂವ್ ಸ್ಲೋಲಿ. ನೋಡಿ, ಇನ್ನು ಮೂವ್ ಆಗ್ತಾನೆ ಇದೆ, ಸ್ಲೋ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಇದೇ ಒಂದು ಇಂಕ್ನ ನೀವು ವಾರ್ಮ್ ವಾಟರ್ ಅಥವಾ ಹಾಟ್ ವಾಟರ್ಗೆ ತಗೊಂಡು ಜಸ್ಟ್ ಒಂದು ಡ್ರಾಪ್ ಆಫ್ ಇಂಕ್ ಹಾಕಿ ಇಲ್ಲೇನು ನೀವು ಮೂಮೆಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ದಿಸ್ ಮೂಮೆಂಟ್ ವಿಲ್ ಬಿ ಕ್ವೈಟ್ ಫಾಸ್ಟರ್. ಈ ಮೂಮೆಂಟ್ ಏನಾಗುತ್ತೆ, ಇನ್ನೂ ಫಾಸ್ಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಫಾಸ್ಟ್ ಆಗಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂವ್ ಆಗುತ್ತೆ ಹಾಟ್ ವಾಟರಲ್ಲಿ? ಓಕೆ, ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಐ ಟೆಲ್ ಯು ಚಿಲ್ಡ್ರನ್, ಈ ಮೂವ್ ಆಗ್ತಿರುವಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಲ್ಲಿ ಎನರ್ಜಿ ಇದೆ. ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್ ಎನರ್ಜಿ. ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್? ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಓಕೆ, ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್? ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹ್ಯಾಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ಹಾಗಾದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಏನು? Kinetic energy is nothing but energy that is created due to the virtue of its motion. ಮೋಷನ್ ಅಂದ್ರೆ ಏನು? ಮೂವ್ಮೆಂಟ್. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಈಗ ನಾನು ಇಂಕ್ನ ಇಲ್ಲಿ ಡ್ರಾಪ್ ಮಾಡಿದಾಗ ಇಂಕ್ ಏನಾಗ್ತಾ ಇದೆ, ಮೂವ್ ಆಗ್ತಿದೆ. ಈ ಮೂವ್ ಆಗ್ತಿರುವಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಲ್ಲಿ ಎನರ್ಜಿ ಇದೆ. ಯಾವುದೇ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆಗ್ತಿದ್ರು ಅದ್ರಲ್ಲಿ ಎನರ್ಜಿ ಇರುತ್ತೆ. ಆ ಮೂವಿಂಗ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಲ್ಲಿರುವಂಥ ಎನರ್ಜಿನೇ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಆ್ಯಂಡ್ ಈ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಯಾವಾಗ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಯಾವಾಗ ಫಾಸ್ಟ್ ಆಗುತ್ತೆ? ವೆನ್ ಇಟ್ ವಿಲ್ ಬಿ ಫಾಸ್ಟ್ ಅಂದರೆ ವೆನ್ ದ ಟೆಂಪರೇಚರ್ ಈಸ್ ಮೋರ್. ನಾನು ಹೇಳಿದೆ, ಕೋಲ್ಡ್ ವಾಟರ್ಗೆ ಇಂಕ್ ಹಾಕಿದಾಗ ಸ್ಲೋಲಿ ದ ಇಂಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ವೆಂಟ್ ಇನ್ ಟು ದ ವಾಟರ್. ಸ್ಲೋಲಿ ದ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ಇಂಕ್ ಟುಕ್ ಪ್ಲೇಸ್. ಬಟ್ ಇನ್ ದ ಸೇಮ್ case, in spite of taking cold water, if I have taken hot water, the same ink particles would have been moved little bit faster compared to the cold water. ಯಾಕೆ? ಹಾಟ್ ವಾಟರಲ್ಲಿ ಏನಿದೆ? ಹಾಟ್ ವಾಟರಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಇದೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ವೆನ್ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. Getting my point? When temperature increases, the kinetic energy of the particles also increases. ನೀವು ಕೋಲ್ಡ್ ವಾಟರ್ಗಿಂತ ಹಾಟ್ ವಾಟರಲ್ಲಿ ಇಂಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ಹಾಕಿ ಆಗ ಏನಾಗುತ್ತೆ, ಹಾಟ್ ವಾಟರಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ದ ಇಂಕ್ ಮೂವ್ ಫಾಸ್ಟರ್ ಕಂಪೇರ್ ಟು ಕೋಲ್ಡ್ ವಾಟರ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಎನರ್ಜಿ ಅಂತ ಹೇಳಿದಾಗ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಯು ಹ್ಯಾವ್ ಟು ನೋ ದೆರ್ ಆರ್ 2 types of energy. One is the kinetic energy and the second one is potential energy. ನಾನು ಹೇಳಿದನ್ನ ಈಗ ಬೋರ್ಡ್ ಮೇಲೆ ಬರಿತೀನಿ, you can note down, ಕೇಳಿಸ್ಕೊಳ್ಳಿ first. Okay, so there are 2 types of energy. Firstly it is kinetic energy, secondly it is potential energy. What is kinetic energy? Kinetic energy is the energy created due to the virtue of its motion. What is potential energy? The energy created due to the virtue of its position. ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈ ವಾಟರ್ನ ನಾನೊಂದು ಜಾಗದಲ್ಲಿ ಇಟ್ಟರೆ ಈ ವಾಟರಲ್ಲಿ ಒಂದು ಎನರ್ಜಿ ಇರುತ್ತೆ. ವಾಟರ್ ಜಸ್ಟ್ ನಾನೊಂದು ಗ್ಲಾಸಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ, ಈ ವಾಟರಲ್ಲೂ ಒಂದು ಎನರ್ಜಿ ಇರುತ್ತೆ. ಈ ವಾಟರಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿದೆಯಲ್ಲ ಎನರ್ಜಿ, ಆ ಎನರ್ಜಿ ಇದರ ಪೊಸಿಷನ್ ಇಂದ ಕ್ರಿಯೇಟ್ ಆಗಿರುವಂಥದ್ದು. ಆಯ್ತಾ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಸ್ಟೋರ್ಡ್ ವಾಟರ್ ಇನ್ ಅ ಡ್ಯಾಮ್, ದಟ್ ವಾಟರ್ ವಿಚ್ ಇಸ್ ಸ್ಟೋರ್ಡ್ ಇನ್ ದ ಡ್ಯಾಮ್ ಹ್ಯಾಸ್ ಸಮ್ ಎನರ್ಜಿ. ಓಕೆ, ಆ ಪೊಸಿಷನ್ ಅಲ್ಲೇ ಇದೆ, ಬಟ್ ಸ್ಟಿಲ್ ಇಟ್ ಹ್ಯಾಸ್ ಎನರ್ಜಿ. The energy which is created due to its position is potential. But ಇಲ್ಲೇನು ಮಾಡಿದ್ವಿ ನಾವು ಮಾತಾಡ್ತಿರೋಂಥದ್ದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಅಂದರೆ ದ ಎನರ್ಜಿ ದಟ್ ಈಸ್ ಕ್ರಿಯೇಟೆಡ್ ಡ್ಯೂ ಟು ದ ವರ್ಚ್ಯೂ ಆಫ್ ಇಟ್ಸ್ ಮೋಷನ್. ಇಂಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂವ್ ಆಯಿತು, ಅಗರ್ಬತ್ತಿ ಮೂವ್ ಆಯಿತು. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಸೊ ಯಾವುದೇ ಒಂದು ಪಾರ್ಟಿಕಲ್ಸ್ ಮೂವ್ ಆಗ್ತಿದ್ರೆ ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆಗುವಂಥ ಎನರ್ಜಿನೇ ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ? ಇಟ್ ಇಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. And when will this kinetic energy increases? The kinetic energy of the particles increases when temperature increases. ಇದಕ್ಕೆ ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬೋದು. ಸೊ ನೀವು ಒಂದು ಪಾನಿಪುರಿ ಶಾಪ್ ಮುಂದೆ ಹೋಗ್ತಿರ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ, ಅಥವಾ ಒಂದು ಲೈಕ್ ಚಾಟ್ ಸ್ಟ್ರೀಟಲ್ಲಿ ಹೋಗ್ತಿರ್ತೀರಾ. ಚಾಟ್ ಸ್ಟ್ರೀಟಲ್ಲಿ ಪಾಸ್ ಆಗಬೇಕಾದ್ರೆ ಯು ಗೆಟ್ ದ ಸ್ಮೆಲ್ ಆಫ್ ದ ಚಾಟ್. ಬಿಕಾಸ್ ಆ ಚಾಟ್ ಸ್ಟ್ರೀಟಲ್ಲಿ ಅವ್ನು ಏನು ಮಾಡ್ತಿರ್ತಾನೆ, ಹಿ ವಿಲ್ ಬಿ ಹೀಟಿಂಗ್ ದ ಮಸಾಲಾಸ್ ಆರ್ ವಾಟ್ ಎವರ್ ದಟ್ ಹಿ ಈಸ್ ಆಕ್ಚುಲಿ ಪ್ರಿಪೇರಿಂಗ್ ಫಾರ್ ದ ಚಾಟ್. As he is heating, the temperature was given to that masala. What happened? It is actually spreading everywhere. The temperature is allowing the particles to spread in the air. That is why the smell is reaching even if you are far. Even if you are far, the smell is reaching you. Okay, why? Because the temperature increased, the smell of the particle, the kinetic energy of the particles are moving faster. Suppose he has shut down the shop. That street is completely shut down. If you pass after some time, you don't get much of the smell that you have been observed before. Why? Because nobody is there, temperature is not there. When temperature is not there, the particles cannot diffuse easily. So I would like to add a word called diffusion here. So make a note of what I told right now. See, particles of matter are continuously moving anta helde. So you have to note here, children, note moving particles has energy. Moving particles has what kind of energy? Kinetic energy. Moving particles has kinetic energy, children. And what happens there? What happens to this kinetic energy? When temperature increases, when temperature increases, what happens? When temperature increases, kinetic energy of particles also increases. Particles also increases. Kinetic energy of the particles also increases. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ರೈಟ್. ಆ್ಯಂಡ್ ಇದನ್ನು ನಾನು ನಿಮಗೆ ಅಗರಬತ್ತಿಗೂ ಕೋರಿಲೇಟ್ ಮಾಡಿ ಹೇಳಿದೆ ಅಲ್ವಾ? ಅಗರಬತ್ತಿನಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅಲ್ಲಿ ರಿಲೀಸ್ ಆದಂಥ ಒಂದು ಅಗರಬತ್ತಿದು ಫ್ಯೂಮ್ಸ್ ಏನಿದೆ ಏರಲ್ಲಿ ಮಿಕ್ಸ್ ಆಯಿತು. ಓಕೆ, ಸೊ ಮಿಕ್ಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಅಗರ್ಬತ್ತಿ ಹ್ಯಾಸ್ ರಿಲೀಸ್ಡ್ ಸಮ್ ದ ಫ್ಯೂಮ್ಸ್ ಅಟ್ ದ ಪ್ಲೇಸ್ ವೇರ್ ಇಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಇಗ್ನೈಟೆಡ್. ಎಲ್ಲಿ ನಾವು ಅದನ್ನು ಲೈಟ್ ಅಪ್ ಮಾಡಿರ್ತೀವಿ ಅಲ್ಲಿ ಸ್ಮೆಲ್ ರಿಲೀಸ್ ಮಾಡಿರುತ್ತೆ ಅಲ್ವಾ? ಆ ಸ್ಮೆಲ್ ಅಲ್ಲಿಂದ ಅಂದರೆ ಎಲ್ಲಿ ಜಾಸ್ತಿ ರಿಲೀಸ್ ಆಗಿದೆ ಅಲ್ಲಿಂದ ಎಲ್ಲಿ ಕಡಿಮೆ ಇದೆ ಅಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ. ಸೊ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ವೇರ್? ಫ್ರಮ್ ದ ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟುವರ್ಡ್ಸ್ ದ ಲೋ ಕಾನ್ಸಂಟ್ರೇಷನ್. Okay, so what do we call this as? We will call this as diffusion. What do we call this as? Diffusion. We can describe diffusion in 2 ways, children. One is intermixing up of particles. What is diffusion? Diffusion is nothing but intermixing up of particles. This is called diffusion. In the second way, we can also describe the movement of gases. What is diffusion? Diffusion is nothing but, just a second. Just a second. Children, cursor is not moving. Just a second. Yes. So diffusion, the another way of describing diffusion is movement of gases from the region of higher concentration to the region of low concentration or lower concentration. I told you, see, when you're getting smell, the smell is actually produced at one area. It was more in that, it will be more in that particular area, and from that region it will move towards the region where there was no smell or where there will be no smell. Okay, andre high region in the low region ge pass ಆಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So movement of gases from the region of high concentration towards the region of low concentration is called as what? It is called as diffusion. Or you can also define the diffusion as intermixing up of particles. You can define as intermixing up of particles. Clear ಆಯ್ತಲ್ವಾ? Right. So this is the second what I can say. I hope you have noted down. If not, please pause the video and note it after some time. Okay, right. The last characteristic of matter is particles of matter attract each other. So this is the last point. Particles of matter attract each other. Is this clear? So how can I let me give you one example for this. Say for example, if I talk about solid ಏನಾಗುತ್ತೆ, solid ಅಲ್ಲಿ ಇರುವಂತ ಈ particles ಏನಾಗುತ್ತೆ, they're closely attracted. Okay, but when I talk about a beaker which is containing water in this beaker, the molecules of water or the particles of water are they're loosely attracted. Okay, but when I talk about a cylinder which is actually filled with the gas, here what happened, particles are very, very freely arranged, so the attraction is very less. Okay, see, you can observe in the solids the particles attraction is greater compared to liquids. Here the attraction is less compared to solid, but in the gases the attraction is least compared to the solids as well as liquids. Okay, or we can also take an example, children. Say for example, say for example, you might have played with the water which is coming out of the tap ಇಂದ ಬರ್ತಿರುವಂತ ವಾಟರ್ ಅಲ್ಲಿ ಆಟ ಆಡಿರ್ತೀರಾ. ಸೊ ಟ್ಯಾಪ್ ಇಂದ ಬರ್ತಿರುವಂತ ವಾಟರ್ ಹತ್ರ ನೀವೇನಾದ್ರೂ ನಿಮ್ದು ಫಿಂಗರ್ ನ ಜಸ್ಟ್ ಈ ರೀತಿ ಟು ಅಂಡ್ ಫ್ರೋ ಮೂವ್ ಮಾಡ್ತಿದ್ರೆ ಏನಾಗುತ್ತೆ, ವಾಟರ್ ಸ್ಟಿಲ್ ಇಟ್ ಕಂಟಿನ್ಯೂ ಟು ಮೂವ್. It does not cut. Will the water cut? No, right? Why? Because the particles of the water has some attraction. Even if you pass your fingers or your palm in between the water, you can just make the water to just stop for a while. But immediately what happened? The water still keep moving. Why? Because the particles of the water have attraction between them. In that case, is it clear? So we can still talk about many examples, children. For today's class, I think whatever the concept I have explained, I think it is very clear. If you have still any doubt, you can ask me in the next class. I hope it is clear. So most importantly, everybody learn about the characteristic particles of matter. So under characteristic particles of matter, I told you particles of matter have space between them. For this, one more example I can take. For example, say if a person is standing in a very height to jump into the swimming pool, what happens? The moment he jump into the swimming pool, easily he can take the place inside the pool. ಯಾಕೆ ಒಂದು ಪೂಲ್ ಒಳಗಡೆ ಹೋಗಕ್ಕೆ ಆಗ್ತಿದೆ? Because the pool contain water and the water present in the pool has space between them. That is the reason he can easily get inside that water, because of the space which is present. In spite of falling in the swimming pool, if he's falling on the flat land ಮೇಲೆ ಬಿದ್ರೆ ಏನಾಗುತ್ತೆ, he cannot go inside, rather he may break his bones. ಹೌದಲ್ವಾ? ಸೊ ಎಲ್ಲಿ ಸ್ಪೇಸ್ ಇರುತ್ತೆ, ಡೆಫಿನೆಟ್ಲಿ the intermixing of particles takes place, or another particle can occupy space between the particle which has space which is the particle which is having actually space. ಅಂದರೆ ಒಂದು ಪಾರ್ಟಿಕಲ್ಲು ಇನ್ನೊಂದು ಪಾರ್ಟಿಕಲ್ಗೆ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ಒಂದು ಮ್ಯಾಟರ್ನ ಇನ್ನೊಂದು ಮ್ಯಾಟರ್ಗೆ ಹಾಕಿದಾಗ ಆ ಮ್ಯಾಟರ್ಲಿ ಸ್ಪೇಸ್ ಇದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಏನಾಗುತ್ತೆ, ಅದು ಆಕ್ಯುಪೈ ಆಗೇ ಆಗುತ್ತೆ. ದ ಪಾರ್ಟಿಕಲ್ ವಿಚ್ ಹ್ಯಾವ್ ಬಿನ್ ಆ್ಯಡೆಡ್ ಡೆಫಿನೆಟ್ಲಿ ಆಕ್ಯುಪೈ ಸ್ಪೇಸ್ ದೇರ್. ಓಕೆ, so saying so much, I am concluding today's class, children. In the next class, I will be teaching you about solids, liquids and gases. Thank you so much. I'll be meeting you all